Good morning, students. Welcome to the video session 7 on magnetic materials. Probably in the video number 4 or 5, I discussed classical theory or Langevins theory on paramagnetic materials. But today I am discussing a quantum theory of paramagnetism. Students, this derivation is very important from the point of examination. It is a quantum theory. You will ask question, what is the difference between Langevins theory and quantum theory and all that? The Langevins theory is completely, it is based on classical atomic model, classical model. But this theory is based on the factor atomic model. In factor atomic model, you know that the spin angular momentum, orbital angular momentum, total angular momentum is represented by Capital J. That is sum of the sum of the spin angular momentum and also orbital angular momentum and all that. In classical theory or in the Langevins theory, what assumptions he made is, suppose there are several atomic dipoles are there, several atomic dipoles. Each atom is considered as a magnetic moment, atomic magnet we consider. Here, whenever the substance is, it is H equal to 0. When the substance is applied to the external magnetic field, then what happens? Depending upon the strength of the magnetic field, all dipoles are they are oriented with respect to magnetizing field. Please, students, don't think that exactly they are aligned with respect to external magnetic field. Don't think like that. Slightly some angle it has made with respect to H. Here you see, so if there is 10 atomic magnets are there, all 10 atomic magnets are oriented with respect to external magnetic field. This is the assumption who made here, the Langevins assumption he made here. I will repeat it once again. If there are 10 atomic magnets are there, when they are subjected to the external magnetic field, he assumed that all atomic magnets are oriented with respect to external magnetic field. But in the quantum theory, they made slight correction they made here. Here, that depending upon the orientation of the orbits, only few orbits are oriented, or only few atomic magnets are oriented with respect to external magnetic field. This is the major difference between Langevins theory and quantum theory. Here, in the quantum theory, not all, only the few atomic magnets, depending upon some conditions, they are oriented with respect to external magnetic field. Now, I will going to derive the equation for this now. And also in the classical theory, I derived this equation, that is Curie constant equal to n mu naught square, mu square divided by 3k. That is what assumptions are made in the lastly what we arrived is the Curie constant in the Langevin theory. Let us see what is the Curie constant in this derivation and all that. First, here, magnetic moment of each atom. Now derivation starts now. Magnetic moment of each atom, if each atom in presence of external field, in presence of magnetizing field, in presence of magnetizing field equal to G mj. This is what we. Here, what is the, you studied the vectoric model, it is called as a gyrometric ratio. Gyrometric ratio. What is mu B? It is called as Bohr magneton. What is mj? It is what? It is mj is nothing but magnetic quantum number. It is called as magnetic quantum number. This magnetic quantum number, it takes what? 2j plus 1 values. 2j plus 1 values. Already stated the vectoric model. If there are j equal to 1, what are the possible values? -1, 0, 1. That means 2 1s are 2, 2 plus 1, 3. So that allowed states are -1, 0, 1. If there is j equal to 2, then -2, -1, 0, plus 1, plus 2. 1, 2, 3, 4, 5. You substitute here. 2 to the what? 4. 4 plus 1 is what? 5. There are the 5 possible states and all that you studied. Now I will rub it. What is here? The magnetic moment of each atom in the presence of magnetic field is given by the equation G mj into what? Mu p, that is. Here in shortcut, this notation I will call it as a what? Mu j equal to mu j equal to this. This is equation number 1. Next, potential energy equal to potential energy experienced by each atomic magnet in external magnetic field equal to U equal to, it is minus of mu j dot b dot, because they're all aligned with respect to what? Magnetic field. Here, of course, in the atomic magnet, in vector atomic model, all atomic magnets are oriented with respect to magnetizing field, with respect to external magnetic field, where what happens? Theta equal to 0, so that A dot B equal to what? AB into what? Cos theta. Theta equal to 0 means cos 0 equal to 1 and all that here. Just I am writing U equal to this value, G mu j, this is what? Mu B, B equal to mu naught into what? H, because we know that B equal to mu naught into what? H. This is the relation between magnetic intensity and magnetizing field. This is magnetizing field. This is called as what? Magnetic intensity, and mu naught is called as what? The permeability of free space and all. This is equation number 2. Next, now here m bar, that means average magnetic moment per unit volume equal to m divided by what? N here. This one I will write in this fashion. It is minus j to what? Plus j. Magnetic moment of each atom, this is mu j, that is mu j, multiplied by how the atoms are distributed, that is given by the Boltzmann distribution law. It is e to the power minus u divided by what? K. What is m here? The total magnetic moment equal to what? Magnetic moment of each atom, each atomic magnet, multiply what? Distribution. The distribution is given by according to what? Boltzmann distribution law, divided by summation of minus j plus of j, it is e to the power minus u divided by what? K. And you know the expansion, e to the power of x, 1 plus x cubed by 3 and all that. Of course, here the minus function is there. Now, can I write that is m divided by n equal to, I will write like this. This term, what is this immediate value? Here, equation 1, g, I am writing. It is mj. Then this is what? Mu b, I am writing. This equation I have written. Into bracket 1 minus u divided by what? K. And this is summation minus j to what? Plus j. 4 divided by summation of minus j to what? Plus j. Then this value equal to 1 minus u divided by what? K into what? T. That's the equation. Now I will substitute the value of u, I will substitute. Now I will rub it this portion out. So here I am writing here what is u? U equal to what? G mu j mu b into what? Mu naught into what? Yes, with what? Negative sign. Here I forgotten. This value I have substituted here. Now space is less. I am rubbing out this term. Now say m divided by n equal to minus j to what? Plus j. This term g mj. This is mu b into bracket 1 minus of minus, it becomes plus this one. This is g mu j mu b mu naught into what? H whole divided by what? Kt. This bracket comes divided by summation of minus j plus of what? J. It is 1 minus of minus, it is what? Plus this term. It is g. It is mu j mu j. This is mu b mu naught into h divided by what? K into what? T. Students, consider this j is a subscript, b is a subscript, mu naught is also what? Subscript. And all that. Now I will expand this term. Before expansion, I am considering some here shortcut methods here. Assume that it is summation of mj minus j to what? Plus j equal to 0. This you studied in the factor atomic model. Next, summation of 1, it is minus j plus of what? J. Already told, if it is 2, then if it is 1, what? How many values it takes here? Minus 1, 0, plus 1. If it is 2, minus 2, minus 1, 0, plus 1, plus 2. That is nothing but what? It takes what? 2j plus 1 values. Then next, summation of, you see, here, mj. That's something I like that, I think. It is mj, g. It is not mu j, this is mj. This also. Yeah. Okay. Now this term, it becomes what? Mj square. It is what? This mj square equal to j into j plus 1 into 2j plus 1 divided by what? 3. Next, I will expand this term. M by n equal to this one I will multiply. This one, this one. I will write g. This is what? Mu b. Summation of mj minus j to what? Plus, because these two are constant. Next, here, plus of this g. What is this? G square I am writing. This temporarily leave it. This is what? Mu b square. This mu b square. Then this is mj, this mj I will take later, and this is what? Mu naught into what? H whole divided by kt, summation of what? Mj square minus j to what? Plus j divided by this term. That is summation of minus j to plus j 1 plus of 1, right? It is all the terms constant I am taking outside. G mu b mu naught into h divided by what? Kt, summation of what? mj minus j to what? Plus j. Just now we have seen that. What is summation of mj? Summation of mj equal to what? 0. Summation of mj square? We know that. What is summation of 1? We know that. Now I will substitute all these values. I will substitute. Yes. Okay. Now, here. Start. This value, you see, this quantity, it is altogether, it is what? 0. So that m divided by n equal to 0 plus I. This term, you say. What is mj square? We know that. This I am writing. It is g square mu b square then mu naught into h divided by what? K into what? T. What is this value? J into what? J plus 1 into 2j plus 1 divided by what? 3. Because this value is 3. Whole divided by, what is summation of 1? I know that. It is 2j plus of what? 1. What is this quantity? Summation of mj equal to what? It is 0 plus of 0. Now I will rub this part. Now this one, m divided by n equal to all this term g square mu v square mu naught into h divided by 3 kt. Then j into j plus 1 into 2j plus 1 whole divided by, it is what? 2j plus of what? 1. 2j plus of what? 1 values. Slightly I am modifying. This h term, I will bring it here. And this n term, I will bring it here. M by h equal to, you see, g square mu v square mu naught. Okay. This n I will transfer here. N divided by 3k into what? T. Next, this 2j plus 1, this 2j plus 1 is what? Get cancels. So that j into bracket j plus 1. Already I discussed. M by h is nothing but what? Susceptibility. Repeatedly I am using this one. Equal to m by what? H equal to. Now, what I am writing? This 3k I am writing here. 3k term. Then n I am writing here. Then mu naught I am writing here. Okay. Next, 1 by what? T I am writing. What are left terms are, which are the terms are left here? It is this term. G square is left. I am writing here. This mu v square is left. Mu v square. Next is this j into what? J plus 1 term is left. Here, all this term together, I will call it as a what? I will call it as a what? Mu j square I will call it as, or I will repeat now. Here, this term, writing this here. This term, I will call it as a what? Mu j square. You see. Now, susceptibility equal to n. Okay. Then this is what? Mu naught divided by what? 3k into 1 by t I will write later. It is what? Mu j square into what? 1 by t. Here you see. All this term, it is similar to this term, Q constant. But only the difference is what? Here mu is there, here it is what? Mu j is there. So that chi equal to c divided by what? T. What is c here? C is called as a Curie constant. This Curie constant equal to n mu naught into what? Mu j square divided by what? 3k. Same what you derive in case of a Langevins theory. But the only difference is what? Here, that is the magnetic moment of orbital angular, total angular momentum of, that is magnetic momentum, we consider that is what? Only mu j. But here, the magnetic moment of all atoms are considered. This is the basic difference between the quantum theory and Langevins theory. C is a constant. And then chi and t, how they are proportional? It is like, or else we can write t is 1 by chi, also we can write it. So that if I plot the graph 1 divided by chi against the temperature, then what happens is, this is the graph. As temperature increases, the chi is what? As temperature increases, or that is this one, susceptibility is what? Decreases. As temperature increases, susceptibility decreases. Or Or else, as temperature increases, 1 by chi is what? Increases. See, both are same. As temperature increases, susceptibility decreases. Or as temperature increases, 1 by chi is what? Increase. So then this is the nature of the graph. What is C here? C is called as what? Curie constant. Students, once again I tell you, this quantum mechanical treatment is very, very important from the point of examination compared to the previous derivations. In an entire chapter, you see, I already discussed the relation between susceptibility, mu, mu r, and all that. That one derivations. The next is what? The basic definitions you have to learn. That is what? Susceptibility definition, mu r definitions, magnetic moment definition, intensity of magnetization, some basic definitions they will ask, and the relation between the magnetic parameters. This is second one. Third one is Langevins theory derivation. Fourth one is quantum theory. They are very, very important from the point of examination. Next is, in the video, I will go to discuss the hysteresis property. I will discuss it. And normally they are asking the questions, some basic definitions, and also what the applications on importance of the word hysteresis. One more thing is that ferromagnetic domains theory. Then these are the 2 points I am going to discuss in the next derivation. Thank you.